Right, oops, wrong one. Right, so guess what? I've got the motor installed. Whee! So the motor can be plugged on that end, or it can be plugged in this hole here, whichever. Because at the moment, well, I glued it on with my plastic glue, but the problem is it's not set properly. It's not completely dry, so it tends to be pulling a bit one way. So the advantage of I've just got a rubber band on it, so I don't put too much force on it, because the plastic is still drying and I don't want to pull it. So the rubber band doesn't have as much tension on it as the dry belt. So the dry belt, I'm just running it off the rubber band. You can run off rubber bands, but they don't last very long. They tend to snap. Yeah, they just melt. Okay, so I've been working on this cogging issue. I wanted to show you something I found out, well, something I figured out from previous tests I've done on other things. If you have two similar magnets next to each other, they create a pushing force which counteracts the dragging force which you have from the other magnet on the other side. So let me try. I hope I don't burn my motor out, because it is dragging a bit. Oh, the dry box. Oh, the rubber bands come off. I was just talking about rubber bands being a problem, and yeah, it's come off. Oh shit! Hang on, I'm trying to get the rubber band on. I'm losing all my speed. Shit. Hang on. There we go, got it on now. It's hard to put it on when it's moving. Right. Ooh. Oh, that's come off again. So what's happening is let me just turn the power off a minute, is that thing's moving a bit. Let me just turn it off a second while, so I'll just stop it. So as I say, I'm waiting for it to dry. So this is not a real proper test. So what I'm going to do is I'm going to move the motor across the other side, and it should lean the other way. See what's happening if you look, it's not that far off. I'll stick it on this side again. This is a good thing about this design. I can just move it across to this side. Oh yeah, it's definitely a bit loose. Right, so we're sticking with. Oh look, rubber band's gone on that. It's got rubber off. It's got that black stuff off the pulley. So all this really is just a. I mean, I've got to wire the new coil. This coil's useless. It's crap. It really is. It's crap. But it kind of helps a bit to put the magnets. Where's my point? Oh, there it is over here. Hang on a minute. So, if you have, say, I'll put the magnet in. This is why I've got these three slots. Oh damn it! What have I done? Oh, stupid phone. Stupid phone. I hope I'm still alive. Oh yeah. Right, I went and put my palm on the phone and it went and made it disappear on me. So this magnet, for example, is pushing south out. Well, it might be north actually, I don't know. And this magnet next to it is also pushing south. So that creates a pushing force against the two magnets. That creates anti-drag against the rotor assembly. So when this gets coggy on here, you see at that point where it's normally sticky, it's pushing, but when it gets in the middle it's pulling. So when these two magnets are precedence in the middle, it's say north and then south, it's actually pulling on the magnetic blocker, the filter, whatever, well, the redeflector, which is deflecting the flux outward. So instead of having a large area of sticking force, we only have a small area of sticking force, because as soon as that rotor is about there, it's actually pushing there. It's actually pushing to the middle, and when it gets to the middle, it's not sticking as bad, because this magnet still has influence over this core material, and also this magnet at this end is the same pole as that one, and different pole to this and this. These two are alike, so these are two like-minded. These are two like-minded relative to each other, and they're basically pushing against each other relative to that piece of block steel. So I mean, well, nanocrystalline core material. So we have less of a sticky effect. I noticed, I tried this, I put the magnets back in because I took them out before. So I put them back in, and I noticed it's a lot less draggy than it was before, which is good. I'm going to turn, I don't know if I can turn this thing back on. Oh, look at my motor, it's really cockeyed, look, it's gone really cockeyed now. It's because I didn't give it a chance to dry. I'm going to take this out a minute. So I wanted to do a quick test, and you can see what's happening. The pillar's bent, look, it's not dried properly, look. I need to leave it till tomorrow. Look at that, I'm pushing it with my finger and it's bending, look. That's what I mean impatient. So that's where the rubber band came off, because it was moving, and it's cracking as well, look. I really wanted to do a test. Just gonna have to wait till tomorrow. Everyone's screaming at me right now. Screaming at me right now. Let it dry, let it dry. Yeah, I do want to. I need to find a weak elastic band. I'll stick it back on this side and let it dry a bit. Right. Maybe I can anchor. Maybe I can anchor it with something. Get my camera mount a minute. I stick my camera in the wobbly cam, droopy cam thingy. Well, I don't know what I can do here, but maybe if I put some, actually yeah, I can put some tape. I can bind it so that it doesn't keep moving. That's what I'll do. I'm just, another way, elastic band around it. Yeah, that might work. I'm going to get another elastic band to counteract the force of this elastic band. Right, so let me just go and find something. Okay, dookie. Right. So if I move this back a bit so we get more in. So if I find an elastic band in here that's about the same amount of force equal to that one, and that one's got oil on it. Oh, it's got rubber on it. Black rubber off there. That's why it's gone black. Turn my meter off because that's running down. Right, if I put the elastic band around here, all the way around the back of here, on that thing, and yeah, maybe it'll work. Maybe, or maybe it's going to slide. I'll have to stick something so it doesn't keep sliding off. Alright, so what I'm going to do, yeah, it keeps falling off. So what I'm going to do is I'm just going to stick something, super glue on there. What can I use? Oh, actually, I can put a screw in the motor. Yeah, better idea. Let's find a little screw for the motor. I can put the band around it. Oop. I'm walking into everything right now. It's because I'm tired. Back to sleep again. Right, if I can find a tiny little screw. Here we go, there's one here. Will that fit? Will that fit that motor? Damn it, I've dropped the damn thing now. Where's my magnet? That'll find it. Where's it gone? Got it. Right, so I don't know if it's, I think that screw's too big. I think it is. It's got threads in the motor as. That's too big. I want a tiny little screw. Oh, here we go. This is a tiny little screw. This might work. Yeah, it's the right size as well. Right, if I can get that elastic band around there. around the screw, under the screw. Oh, I haven't got enough screws sticking out. That's some bad words again. Come on, get underneath. If I screw this out too much, it's not going to go under, it's going to fall out. This is all very ad hoc. This rubber band is too fat. Okay, I've got another idea. I'm going to get a bit of wire, wrap it around the screw, then put the rubber band through the wire. Right. I know what. A little bit of enamel copper wire, very thin stuff. So what I'm going to do is I'm going to put two elastic bands. Oh, I lost the other elastic band. There it is. Right. So I'm going to get two of these elastic bands because I need more tension to pull it back the other way. I've got two elastic bands. I'm going to put this copper wire. The camera's over here. And I'm going to twist this wire together and hook it on that screw, because this flipping elastic, this rubber band is just too fat now. Definitely won't get two on there. So twist this wire around like that, make a little hook or loop, or hook a loop, and we're going to stick that on the screw, the copper, and then I can this wire is so frigging thin I can't even see it. I need a torch, that's what I need. Right. Right, got it. Now I'll put the elastic band. I hope I've got enough tension on this damn thing. Better be. Around the back, underneath. Right, I think that's going to hold the motor so it doesn't pull off, because I'm just letting it dry, you see. Yeah, that works. Okay. You see, I actually lost a bit of tension when I put the wire on there, so I'm hoping that that's going to be enough. So that's going to pull the motor that way, and when I put this dirty rubber band, which I can't seem to find right now. Oh, where's it gone? I put it somewhere, now it's disappeared. I can't believe it. I just had it. Where is it? Oh, it's here, under my nose end. So that should go on there without pulling the blooming motor off. Oh, we should be alright now. I just want to get this started. I don't want to send several amps into my motor and burn it out, because the supercapacitors are fully charged right now. Keep going. Alright, it's working. It's working. Right, so I just want to test move this out of the way because I want to get the meter closer. Good thing all this is plugged in, otherwise there'll be shorts and sparks lying around. Not really. It's all current limited. Get my meter turned on. We're on current. So that's 27 milliamps. 27.8, still climbing. You can see that. Probably not. Maybe if I tilt it back a bit and rest it on something. Maybe. Don't know. Maybe you can see it now. Well, bring it a bit closer. Well, maybe. Yeah, I think you can see it now. I can see it on the phone. So, right. So we're measuring current. And it's climbing in speed. Obviously, it takes a while to build this thing up in speed. And input current at the moment is about 280 milliamps. It's still picking up speed though, and I'm only running it at about 7 volts. I'm not sure, to check. Let's go over here and have a look. I'm waiting for this. Let's get this thing out of the way a bit. Yeah, it's still picking up speed. I'm running at about, well, it's actually getting about 5, 6, 7, 8.5 volts right now. It's not even at 12 volts, so 8.5 volts. But we're current's dropping as it's picking up speed. I don't want to go any higher than that because I'll burn it out. I'm closely monitoring the temperature right now. Let's flick this onto hertz. Well, let's go to hertz. We'll see what I'm thinking. 320 hertz, 330 hertz. I haven't got the RPM thing hooked up. 2 volt range. We're 0.259 volts picking up AC. 2.6 volts AC. Oh, remember, this coil is shite. It's garbage. It's not wound for this, but I'm just testing with this because I used this when I first did the test on the other one. So I just wanted to, until I wind another coil, I'm just using that thing. At the moment, what I'm trying to do is just reduce the drag. I'm trying to optimize drag and get rid of it as much as possible. So this, putting them extra magnets in, seems to have helped actually, and seems to help the output a bit as well actually. I mean, this coil is crap and it's doing better than it was before. So, and we're not even running it very fast. You wouldn't be able to believe. Let's find out what speed this is running at, because I really want to know. We're really not going very fast enough. I mean, this thing is hardly moving right now. Come on, thing, work. Oh. Only 1,319 RPM. That is nothing. We're nowhere near the maximum speed. Let me just try and show you. Come over there. I'll have to hold this thing because I haven't got room to put the flipping thing to hold this RPM sensor. So I'm just going to hold it there. Right. That's the speed at the moment. Oh, I've moved my arm. Sorry. Hang on. Right. There's the speed. 1,320. It's still climbing. Okay. Right. 1,322 now. Still climbing. Yeah, I'm going to hold this damn thing. I need to mount. Actually, can I mount this up here? Oh, maybe. Oh, that's a point. That would be good if I could. Yeah, I can make something to fasten onto this top leg and have this RPM meter dangling. Yeah, that's what I need to do. But not right now, because it might fall and jam up the machinery. all I'm interested in is if it slows down. And you can tell that by the fact that when you put the load on it, if the current starts dropping, you know it's slowing down, don't you? Oh, it's obvious. So let's put the load back on it. And we're seeing 29.5 milliamps. If it keeps speeding up, then we're still good. 29.5 milliamps. I'm a bit wiped out at the moment because, well, it's been a bit of a long day. I have to go to the post office and run around and do a bit of shopping, and also try to get this thing together. And the point is, it's not dropping, is it? As soon as I clicked onto current, let's go to frequency a minute. Actually went up just then. We're at 330 hertz. Current 29.4 milliamps, 29.5 milliamps, 29.6 milliamps. Still climbing in speed. Obviously it's not a usable voltage really, just under half a volt is ridiculously small, but yeah, we'll get there eventually. Once I get a decent coil one with the right gauge wire, and I've got loads and loads of turns and I don't give up and get tired of winding wire on it, once I get enough wire we should have a decent voltage. I mean, that thing is really not much wire on there at all really. It's 30 gauge, it's 30 SWG wire, so I couldn't get enough on there. It was starting to get too fat, and the further away from the rotor you get, the worse it gets. So there's no point in winding a fat coil because the wire's getting further and further and further away from the rotor, so it gets less efficient. So that's why the new coils I'm winding are actually wound on the actual canopy, and they're all spread out evenly, quite wide over quite thinly over a larger area, so that we actually get better coupling on all the wire against the rotor as it goes round. We're still climbing in speed. I wonder if my my elastic band support system is working. It's not bending. See, the thing is, if this gets bent too bad, I just plug it in this hole in the other side and it'll be bent the other way. I can always straighten it out. It's just that I was eager to get this thing running, and oh yeah, I've got the good bearings in here right now. What I mean by good bearings is, I mean they've got grease in them, so they're actually a little bit quieter than the other ones, because I washed all the grease out, and I wish I hadn't, because all it did was make them really noisy. Because somebody said, oh well, if you wash the grease out you'll have less friction. Yeah, right. No, actually all it does is make a lot of noise and wears your bearings out really quickly, and they get really loose after a while. So, but it's alright if you're working on something that's got very, very, very little torque, like electrostatic motor. I mean, those things you can stop them just by breathing on them. Oh, that's the thing. When I was packing that package in earlier, I was using polystyrene, and I had to break up all this polystyrene into little chunks because it was big solid polystyrene. I was breaking it up, and I tell you what, a freaking nightmare. That stuff was stuck all over my hands. I looked like a blooming yeti. I mean, you wouldn't believe it. You wouldn't recognise me. I was covered in these polystyrene beads all over my arms and I was brushing it off. I was going like this, get off. And when I did that, I just picked more up, and it was all over my arms. It's like, shit, what do I do to get rid of this stuff? So there's all this polystyrene stuck to me because of the static, and I couldn't get rid of it. And I thought, oh, I see some on the bed over there. So I went to grab the stuff off the bed, and then I went and left a load more behind. You know, it just, yeah, you wouldn't believe the mess I was in. I thought, shit, what do I do? And then I realised, I'll get my spray, which has colloidal silver in it, the one I rejected, I couldn't drink, and I thought, I'll spray that everywhere, and that'll kill the static. And yeah, it did. Just made my bloody bed wet, that's all. So now I've wet my bed, and yeah, so now I'm going to wait for that to dry out a bit before I can go to sleep, because of that frigging static. So talk about an eventful day. I lost the phone now. I just realised I'm using it to film this video. Oh, I'll tell you, I'm losing it, I really am. So we're still climbing in current. As you can hear, it's as quiet as a mouse. No vibration at all. That I can. They're a very slight amount. Is that rubber band going to come off again? I think it is, you know. The back tension I'm using isn't sufficient because I can hear it slowing down. Yeah, the rubber band was sliding off. Look, see, it just slid back now. I need more tension. Yeah, when the rubber band gets to the end of the pulley, it starts to drag on the edge wall of the pulley, and that creates friction, and then it slows down. Yeah, I think I've fixed it temporarily. Well, I know what's happening. The motor's warming up, and as the motor warms up, it makes the plastic at the back start to get soft. Yeah, the motor's warm, but not hot. You need to push it back a bit. Come on, don't fly off. Yeah, it's gone back a bit. I have to keep my finger on it now. The heat from the motor is making that gluey plastic that I'm using go even softer. Doesn't need much pressure to hold it though. It's going to come off again. Go back. So about 30 milliamps near enough. So I've still got to sort that cogging out. Some of my magnets have got displaced a bit in the slots I want sorting out. They're not. Some of them are staggered a bit, and I need to sort them out a bit. We get this right in the middle, which is difficult with this rubber band. I think the motor's got warm enough that the plastic at the back is just starting to melt. Oh, it's still not dry, you see. It's the acetone. It just makes it softer when it gets warm. The motor's not that hot really. I don't know if I can show you. I've got my temperature gun working. It's going to come off in a minute, that rubber band is. Let's see what temperature it is. Yeah, the motor's reading 31 Celsius, 33. 33-ish. So it's not that warm. It's definitely rubberized. I'm gonna have to take this rubber band off actually, because it needs to dry. Anyway, put it back on voltage. I'll take this band off now because I want it to dry. So I'm just going to take the band off by doing that, which was disconnect the power to the motor, because this thing is going to get cocker. It's definitely gone soft. Where's my band gone? There it is. So it's basically freewheeling, and you can see there's still quite a bit of drag on it because of the cogging effect. Oh, it might be because of the bearings being a bit stiffer than the others as well, but oh well. Definitely not as bad as the cogging's definitely not as bad as it was until it gets right in the middle. Then you see it speed up, and that's because my repulsion idea does work. Because when it's actually above the two magnets that are pushing against each other, you'll notice that when it swings all the way to the end, the frequency is lower, but when it gets in the middle, it speeds up. Now watch this. Right to that edge. So these magnets in the middle are a lot stronger, so when it gets into that point it can pull more, but as it gets near the edge it's not pulling as much, so it's weaker, because these two magnets are pushing against each other through the steel, so there's a bit of repulsion there. Right, so anyway, I'm going to end because my battery's going to want charging again. I just wanted to show you that I got the motor. It'll be dry by tomorrow. It'll be alright by tomorrow. Can't get the damn phone out now. Come out, you bugger. It was stuck. Somewhat. Right, so without pressing any buttons, so all I have to do is take that rubber band off the back, the support thing, pull this out without pulling it off, hopefully, and you see it's gone cockeyed, look. I'll straighten it out a bit and let it dry because it's still not hard. Right, I've got it straight now, I think. I'm just gonna stick it. Oh my god, look at that rubber band, it's gone black. So all that black rubber that's come off the pulley there, it's rubbed off onto that one. I'm gonna leave it in this one because I can see it better, and I'm gonna let it dry overnight. I'm going to have to take these off here now. Actually, luckily it's on a screw, so I can just unhook it like that. And actually, I don't want to lose that. I don't want to lose that screw, so I'm going to tighten it up so it doesn't fall out. That little thing there. Might need it, because I hope it don't catch on the commutator. I'll check. No, you got to make sure you don't use really long screws, because they can ruin the wires on the commutator, rip the wires off the thing that spins around. That's the commutator thing. And this screw is very short, so it's not catching. That would be a bad thing to happen. It would ruin a new motor, because this is a new motor. I'm just going to push it in so that it's straight, so I can seal the gap between there and there, make sure it's dead straight. And I'm going to leave it on this rubber mat, because I'm going to go to bed in a minute or two. And that'll dry overnight, and that should be dead straight by tomorrow. Let's just spin it up to make sure it's not catching. No. Anyway, that's it for now.